Hi, so my presenting partner here is Shemad Lakul. He's a super engineer. He's been doing a lot of semantic web for a number of years, a lot of enterprise. Maybe actually you should say a few words about yourself. All right. As far as me, I started out my career as a Java developer. So I feel at home here. For the last few years, I've been in the semantic web space. I've been starting companies, building semantic software, semantic search. We'll talk about it later. And also write for devx.com, which is a development site. You guys you've used it, on topics of entrepreneurship and semantic web. Okay, so this is kind of what we are covering. What is the semantic web? You know, there's a whole bunch of technologies. They kind of all sound weird. There's RDF, which is a basic modeling, very basic modeling mechanism. RDFS, which is just kind of one level deeper, and you can do a lot more things, and you can manipulate data in a number of different ways. And then, I can point. Yes, Sparkle is the query language for the semantic web. It's the standard. There are a few, but this is pretty much the standard. RDFA is the open web kind of Google's adoption of sort of in the SEO community. It's a standard. We'll talk about it a little bit later. Linked open data is just the general semantic web kind of vision. And OWL is really the next step after RDFS. It's a really heavy-duty modeling tool. And so we'll get into that later as well. This is just kind of what we're going to talk about. So does anybody know who this guy is? Tim Berners-Lee. So he's the guy, I think, I just had a thought today that he's the guy who invented Web 1.0. Like, he gets the credit for that. And he's the kind of guy who invented Web 3.0. He gets the credit for that. But I don't think he gets any credit for inventing Web 2.0. Because that sort of innovation, which is generally the business world, and making technology kind of commoditized, and really putting things into the business person's hands, right? That's the Web 2.0. Very easy, done. There's no technology risk in Web 2.0. It's all easy. It's very non-tech. But that's the most successful web, right? Web 2.0 is the most successful web, right? Web 1.0 was like the precursor. Web 3.0, I don't know, it's coming, it's getting hype, but that's what he gets credit for. But Web 2.0, we are here, and this is the most successful web. He does not have a big role in that. Okay? All right. So a lot of people say semantic web, but actually it means so many things. So before I actually talk about semantic web just means so many different things to different people. Like library scientists, they like to talk about taxonomies, like data collection, right? Things like that. Organizing data, putting it into context. So if you have an apple, I don't know if it's a fruit or a company, but if it's in a taxonomy, it has context. It's a subclass of a company or a subclass of a fruit. You know what it is. So these are people who deal with taxonomies, are people who organize data. They and they really create these ontologies, which is basically a term that's borrowed from philosophy, which means, in philosophy, I think it means just how things are. That's a study of how things are. And so the ontologies, the taxonomies, when they become more mature and bigger, they generally become ontologies, where you define more relationships between things using these things like I mentioned, RDF and RDFA. Okay, so the open web and this linked data, it's kind of one and the same. And it's different than taxonomies and ontologies. So I should have kind of flipped them, but it's okay. Generally, the open web and this whole notion of linked data was his vision. But he's a theoretician. He wanted to unite the web. He wanted to really, have some things mean the same thing everywhere in the web, which are kind of happening now with Facebook, right? Facebook Connect it's all over the web. So in some ways, other people are doing the same things, but in a very different way than he is doing. But that was his vision, is to really unite the web, because there's all this data made every day, and it's not organized. It's just living somewhere. It's only connected by links, and it's mostly documents. And what he wanted to do is connect the actual data. And he wanted to create this huge open web that just makes a smarter web. That was his vision. Now, another aspect of something you might think of Semantic Web, or a lot of people come to Semantic Web thinking that that's what they're going for, is this aspect of reasoning, which is a very interesting, it's another totally separate subject. But it's another like kind of under the umbrella of Semantic Web, and a lot of people get this has a big allure. And are many people familiar with reasoning, what this is? Okay, so this is very cool technology. I think it has its roots in AI. And it's basically, you say A goes to B, B goes to C. That means A goes to C. Very simple logic. But A goes to C, you don't have to state that. You apply some software called Reasoner, which automatically tells you that A goes to C. So you have some data, and when you let a reasoner run over it, it actually connects logical paths in there and gives you more statements, more knowledge out of the data you already had, right? So it's very useful for business, potentially. Is that clear? So any questions about what reasoning is? I know you know. It's just basically you get more data, you have a set of data, you apply a reasoner to it, and you actually get more data out of it, like for free. Okay. NLP, natural language processing. Is anybody familiar? Yeah. So it's basically a way to convert human language into machine understandable language and back for whatever uses you have. Maybe you don't need to go both ways. And it's very useful in conjunction with taxonomies and ontologies. And a really big strength of the semantic web is that combination, where you actually you have sort of things in context already. Like you have already knowledge of what the apple is, right? You already know that the apple is a fruit. You're not talking about the company. So in NLP, you just basically have to extract this entity, hey, apple. And when you combine it with the rules in an ontology and in a structure, you know what that apple is, and you have rules attached to this concept. So like this, now you know when you encounter, like if without semantic web, without the stuff, you encounter apple, your software is dumb. It doesn't know what it is, right? It doesn't even know if it can be a company or fruit. It doesn't know anything about it. But if you extract it using NLP, extract it correctly, and link it up to all these knowledge and structure and rules, you now can do all this amazing stuff with it, right? Like Apple, yeah, you're doing farming, okay. So like, I mean, to get to this point is hard, but once you are able to really use these two in conjunction, because they are also two very separate fields. This is like linguists, and this is library science. So there's two very different fields. You probably, very few people can do both at the same time. They're very expensive, very. And if you find, it's like you can't find one. And if you find one, it's too expensive. So it's like, so basically, it takes two people to do this, and they're also expensive by themselves. Anyhow, and then so this is very separate kind of fields that are brought together under this umbrella of semantic web. Okay, I'm kind of taking too long on this, but it's important because just people say semantic web, it just means so many different things. Then there's semantic web for business, which don't care about open data, OpenCore, just care that some of these technologies. So forget anything, forget this guy. Right? Oops. So these guys just care that it works. Okay. That's all. I mean, if any of these technologies, it becomes commoditized, right? Like they're glorified on their own, but here they're just commodity. Nobody cares, right? Just make it work. Use one of them to make my existing use case work. So you never start, almost never. And you almost never start in this with any of these, right? You start, what problem am I solving? Okay, let's try it. Let's do it easy. Okay, we really hit something that we cannot do on our own. Let's use one of these or this. All right, there's the smart web, right? Everybody wants applications to be a little bit smarter, and you basically have to use the stack. And basically, I just kind of threw it out there, smart web, because as people are saying, but you know, it's like kind of has its one shoe in every one of these, right? But it's, what is that? But it's a buzzword. Like smarter applications, yeah, all this stuff. Okay, so improved search. All this Bing and, I mean, my feeling is that Google's like way more semantic than Bing. I mean, they're so much more mature. You know, as a product, they are. It's like so. There's three parts. You know, the indexing, the crawling, and the actual search. Yeah, I mean, one major difference that I guess deserved its own slide was that the traditional web just linked documents, where the semantic web is meant to kind of link bits of data, right? So the data is linked, the actual meaning of the stuff, not just the documents, right? Semantic web advantages. So we really touched on this. And I really want to kind of spend a lot of time on the overview because it gives a sense of all the reaches of semantic web and what it's really about. So universal data, so yeah, oops. RDF basically is just a really, it can be anything, it's like a language, but the whole point of it is that it's unified, right? It's just one thing across the web. That was his point, right? Okay. And RDFS is you're basically adding more rules. I think there's a slide later to see the rules, where how you can manipulate logically the data. And OWL is like extra more rules. So if you really want a robust kind of like really smart thing, use OWL. Most applications just get by with RDFS. You can also make your own rules. They just won't be universal, right? And we'll get into it. And then Sparkle. We covered it a little bit. Just a query language. We'll have an example later. Information, and then reasoners. We also touched on that, right? Pellets, the big one. I keep forgetting the really interesting reasoner from IBM. Use cases for semantic. So we really covered a lot of this, right? As long as you want, I think the bottom line is, as long as you want a certain context for your data, as long as you want to do something extra to it, you're not just satisfied of like showing it somewhere. You actually want to use it to get further, like a recommendation, like it was a very good use case because this local advertising is huge, right? Everybody's after that now. So XML, basically, we're talking about this RDF, RDFS, OWL. What is that? It's nothing but XML format. Okay. They have some unique things about it. But it shouldn't be too confusing. There's just way to write it. XML, you can write it in other ways. There'll be an example of that. So it's just, you know, you're trading XML, but it's kind of like interesting XML. Okay, so, and now we kind of see it a little bit. It looks a little bit strange, but it's easy, don't worry. There's an important concept of a namespace, which is basically, that's kind of the thing that makes it universal. Okay. So like this is a namespace, like all the way from this hashtag, from the NS, all the way to HTTP. You know what that thing is? It stands for something. It like goes to one thing, right? It's always resolves in that RDF syntax, right? This is the library for RDF syntax. That's it. That's the namespace. And after the hash, you can put different things like type. Something is of type, like object or something like that, right? So then that's how you kind of manipulate it. You don't really need to, like you'll never, if you program the stuff, you'll never manipulate it by hand, right? There's editors, but you have to kind of just know what the stuff is. Just, I don't know why you would want to know. But essentially, you see how it's like really long and dirty? You just make it like a prefix, and you just call it RDF, right? So this whole long, dirty thing, you know what it is? It's a namespace. It's the same all the time for that thing. Okay, just name it RDF, and then, you know, you have it right. Okay, so the question is this borrowed from XML? And the answer is
this looks like XML, but the key difference is it has borrowed a lot of concept from XML. So you'll see namespaces, you'll see schemas, okay, all kinds of stuff like that. Even the query language But the key difference is in XML, everything looks like a tree, right?
Okay.
You have a structure,
You have a root.
you have a root, you have a sub root, and then you have value under that and all of that stuff, right? But in RDF, the structure is a graph, which I hope you will cover it later. That's the key difference. XML data structure is based on tree. However, the semantic web data structure is purely based on graph.
So this URI, so this universal resource identifier, is basically like this, right? So this thing, and it's kind of weird looking, and when I first saw it, I was like, what is this? Why do I need it? And it doesn't resolve, right? It doesn't resolve. If you put this into URL, like it may or may not resolve. That's not the point of it. The point of it is just to have this like universally identifying entity that you always can go back to, and you know what it's talking about, right? And this was the whole point of this whole like open web, link web, where all the different sites that are talking about different things, they kind of have some really unifying underlying things that can really, you know what it is, right? So it looks kind of weird. There's a whole bunch of things here, but it's like a URI from some Silicon Valley code camp. I don't know, like some random thing. But the idea is that whenever you see it, you know that it's talking about some vocabulary, some taxonomy or something. Now you saw kind of how this stuff looks like in code, but let's take a little bit of a step back and like how is this stuff linked, right? Okay. So it basically, if you take one English statement, like I am home or something. You have in that statement you have a subject, a predicate, and an object, kind of. I'm not a big grammar expert, but kind of, right? You have the subject, which is I, home, which is the object, and you have something about me. I am home, right? And all the sentences are kind of like that. All the statements are kind of like that. This is the simplest form of an English statement. English, yeah. And what happens is, let's say you have I am home. You can also say something about home. Home is nice, right? And this is how things would link up, right? So just like English sentences link up, so there's this data, not documents, like the present web, right? But this, the actual data links up, right? So you can link up home. And then you can link up this like object home, right? And you can go some other ontology somewhere else, like I'm actually pointing over there just to exemplify the point. Some random, right? And you can connect it, right? So you can reuse this. It's like universally reusable stuff. And this is how the stuff gets, this data gets connected to other data that's sometimes related, sometimes not related. And so this will be kind of like an example. My house, it has a color. I don't know what this color is. The Pentatone, it has a red component, right? So you see how this stuff is connected. Now notice also that getting a little bit too detailed, but this is kind of like a solid object, but this is actually a literal. So just be mindful of those sort of things. Like you can't really connect the literal very much. Okay, so graph. Right, this actually doesn't look a whole lot like a graph. It doesn't look that different from a tree, but it's like a weird concept. But a tree, you have to attach to a node somewhere. A graph, you can actually just place next to. I think the properties in computer science of graphs is that they're kind of unique, and then you can just place another graph next to it and link up things without this hierarchical data, right? So there's a start and an end, and it's like formal, right? The tree. The graph, it doesn't have to have that. You can just add stuff, interlink it however you want, not in this hierarchical thing. And it's just a more powerful data structure. It's just more flexible. It gives you more that you can do. Okay, so this is a very good question, and to repeat it is, you have a lot of data. It's underlined by some schema is underlying this data. And what happens if the schema changes, right? Or if what happens, you have to go and retype all this data, right? Or do something with it. So it's a very common problem. It's a big concern. Generally, the core stuff doesn't change. Like if you are using some Or it depends if you're making your own or if you're reusing some. If you're reusing some big one, that's like, they tend to be so high level that they don't really change, right? The main things don't change. Like if you're a friend of a friend and there's that kind of thing, that sort of human concept doesn't change. And so it's just not going to change. The data is not going to change. Where people run into this problem is in like enterprise stuff, right? Your company's data really, the way your company is operating changes every month. And it becomes a huge pain. And there are no 100% automated ways to change that. And this is a big problem. Like if you go and pitch enterprise companies, they'll say, hey, you know, when you start talking about scaling the stuff and like, hey, in many cases it doesn't scale. Just to underlie a point, like make a point that you don't have to actually write the stuff in XML. This is a way to represent this not in XML, right? This is something called NTurtle Triple. I don't know who names these things. Why is it turtle? I don't know. But I don't know if you know. But the idea is basically, I mean, this is like a little bit, easier to read. It's less cryptic, but it's just you're representing the same stuff as you did with RDF. Okay, this is kind of interesting. There's a whole new emerging sets of databases, right? Because you're storing these triples. It's not like relational, right? So there's these RDF repositories. We'll actually have some code examples of how to program these and how to set this up with this some open source tool called Jenna. Again, using the Sparkle queries and things like that. Okay, so this is stuff you can do with, this is now you're doing modeling, okay? So this is the kind of stuff, like on the left, it's less interesting. It's like what stuff you can have, like a literal, right? Resource, which is kind of a class, and a class, which is kind of a class. A property, which we talked about, which is like a kind of description of something. Then you have, different, like sequence lists, right? That's these. But the interesting thing is it becomes here. So these are like standard, right? It's commoditized, the standard. The real modeling comes from this side, right? Because you really beginning to do really interesting things with the data. Like not always. I mean, like label. Who cares, right? It's just another way to call something. But sometimes you can say that something is the domain of some subject, and sometimes it's not. And sometimes it's in the range of some subject, and we'll get into those kind of things later. It's a little bit more advanced than like this section at the beginning. But you are beginning to do some, still you're doing some very standard things, but some of the possibilities, they are becoming more advanced ways to model your data when you start, right? If you have like something kind of, this is sort of the beginning of something like in semantic search, like these two, right? Or even the label, right? Because there's some concept in semantic search called concept clustering, and it's a big deal in semantic search. Basically, if you have, if you're searching for a nanny, you also want to find a babysitter or a homemaker or an au pair, right? So it's semantically the same. So it's under the same concept. So you want to kind of have a way to cluster this, and you can label it, these things in other ways. You can call them other things. Where was this other ones? See also, right? You might like a recommendation stuff. But it's still kind of basic modeling because it's just RDFS. OWL has more. The Sparkle is the query language. We'll have some examples of that later. This is it. This is the example. So basically, it's very cryptic, but it's kind of simple. So basically, you have all these namespaces that are very long up to the hash, right? And what you just say is the first 4 lines is you basically got to make a shortcut for each, right? You call this whole big line, you call it DC, right? And then you look for statements. So select this thing. This looks very familiar. The field you want. Where? This is like all familiar stuff. And then instead of the relational joins, you kind of do these sorts of joins. You join on So this is an RDFS type, right? RDF type, sorry. And this is an object from this SVCC here, right? From this library. And you want to see what is the subject, right? For this predicate and this object that's, also here, that's also matching with this pattern, and it's also matching with these patterns where, this is maybe not a good, first query, because you don't want to have all these joins. But basically, wherever there's a question mark, you kind of have some data that's missing, and whatever matches the pattern, like something here, right? You get it, right? It's hard to kind of explain from the first. You don't have to program this tomorrow, so. But you get, is the idea clear of how you're pattern matching, right? Because these are just statements. They're separate statements, right? They live anywhere in the graph. So what happened is these people they went and they created all these ontologies, taxonomies, and this is a very popular graphic you can get on Wikipedia, which it means it's true. No. So OpenCore is a big one, Freebase is a big one, all these other ones, they kind of connect, they kind of don't connect, they're kind of painful to use sometimes they're very useful, who knows. Obviously, I don't think any single person have used all of them. That would be funny if any single person knows any of them. But these are basically libraries out there. You can reuse them as you like. They have generally very well-defined concepts. And the concepts come with universally understandable attributes. So you really just can reuse stuff that's potentially understood all over the web. Some of these, they're not as universal. Some of these are very universal. I'm trying to find one. Many people know Freebase. I don't know, OpenCore, this is part of Reuters. Yeah, so the question is, can you just connect? Yeah, it's all open source. It's all open. You can connect to it any time. Do whatever you want with it. If it's useful, great. If it's not useful, just move on, right? But it's people who have attempted to create standards, right, for different things. This is very different. Some of it is medical, some of it is social, but every field has one of their own that you can just reuse. And because the whole idea of this, right, the notion is that at some point we're going to really, really use all of this, and the web is going to be unified, right? If it's not, it's pretty useless. If it's 10% of the web, it's useless, right? Who needs it? I just use Facebook Connect. That's my semantic, right? But if Tim Berners-Lee vision really comes true, and the web is really, really using all of this, every piece of data is really underlying this, super useful, right? Because it's totally standardized, right? So the use of this really depends on, is the semantic web is this going to really become universal? I think I'm kind of taking a while talking about this stuff, so I'll go faster, even though it's a more complicated topic. The question of defining an instantiating ontology. So it's a heavy-duty modeling tool, right? Even more than RDFS. You can do more stuff. This stuff is very probably out of the scope of this talk, and then it's basically versions of OWL, because the OWL committee, whatever they are, in Boston somewhere, can agree. Okay, so that's why you kind of have different complexities of OWL and different completeness of it. I haven't looked into it, I've used OWL, the basic one. Okay, so this is what it does. So this is the tools it gives you, yeah. So you can see very different logical tools. Other sets, inverse of, if something is that, this is the opposite true, right? So you can do all these logical operations. These are advanced. Inverse stuff is interesting to use because sometimes things work in one way. Is it bidirectional? Same as equivalent is for properties, right? You have the same stuff from RDFS and the classes, cardinality, blah blah blah. Basically, more tools. When you kind of have to see what your use case is and see what's useful for you for your particular software that you're making. It's hard to go through all of these. In general, I would say people get kind of I know technologists, they like complicated stuff. And what I've seen is people want to really use this and make use of it. But they never actually, you have to have a real use for it, right? You have to have use for something that's a union. Maybe it's useful, right? But not all of these are that useful. But they are for, So it's only if it's useful for what you are doing. And this is a really important thing to keep in mind because it's easy to get carried away because there's no restriction. You can use like a whole bunch of these logical operations. And you can also make your own. They just won't be universal. Like this is very like universal. Everybody understands. Oh, okay. But you can also make your own. Just won't be, adapted unless what you're making is good. And so you can see it's like I would get into it, but I think I'm like going slow. So I think I should. This will be it's like a big thing, comparison of these things. Any questions? Is it confusing? Is it too slow, too fast? They complement. Like usually OWL lives on top of RDFS. Usually it's like RDF, RDFS, and OWL. And the most basic thing is XML for sharing data. Right. So we'll just move on because it seems like endless slides. It was like didn't seem that many when it was like looking at it. Advantages of RDF and OWL. Obviously, expressivity. You can just do more. It's adapted, it's distributed. Easier data interchange. Once you understand how to use it, it's easier. Reasoning and inferencing, that topic from the beginning, you can perform on it because the logical operations. That's another thing, is that once you use the standardized stuff like RDF, RDFS, OWL, the reasoners, they know them, right? They're much better at inferencing over existing adapted libraries than stuff you would make on your own, right? So sometimes yes, sometimes no, but like reasoners don't know what you made at home, but they know what's standard. So this is some companies or tools that if you're planning to use this stuff, these are like the leading things. If you are planning to program, like if you're a Java programmer and you're planning to program, like today with Java, you got to use one of these frameworks, and we'll actually we'll have a bunch of examples, thanks to Shemad, on actual like really simple few lines how to accomplish a whole bunch of stuff in Jenna. Jenna is just basically a framework for doing stuff, like write to a semantic database, read from it, manipulate semantic data, stuff like that. Sesame is like a same thing, but less adapted version of it. So it's like, this is the leader, this is the second guys. Then if you want to, this is for messing around with the code, right? This is if you actually want to try to make taxonomies and ontologies, if you want to make them on your own, because that's what you're going to mess around with here, right? You're going to make the ontologies, read them in with this, right? So this is free from Stanford. This has a free and a paid version. I mean, this is like for messing around, Protege, and this is actually if you're really serious or your job can pay for it. RDF repositories, very interesting topic because big question in Semantic Web is scalability of the data repository, because the statements, they are so small in nature, they're just one statement, and so there's just a lot of them. And often it's hard to query them, especially if you're new to modeling data with semantic data, and like you made some like modeling like not best practices decisions. You're probably so you're gonna experience like different scalability issues with it. I believe these guys are in Oakland. They're nice guys. They actually host some semantic stuff events, and they're pretty cheap. They're like, compared to Oracle, which is like if you want to go bankrupt, that's like the best way. Alalim, they're European, virtuoso. I don't know them very well. These guys are out of Bulgaria, I think. Okay. Now, what are the popular libraries that like really you can reuse today that they're pretty stable? Okay, FOF, friend of a friend. It's very simple. It's really, really simple. It's small. It's good to start with. It's pretty useless. Like friend of a friend. You already have Facebook. Okay. Like, I don't know what else you're going to do. OpenCore is like for documents. I don't really use OpenCore. I think it's documents. So if actually Dublin core is sometimes used in RDFA microformats because you want to underline like title and things like that. Good relations, if you have a shopping application or something like that. I tried to use it. I didn't find it totally helpful. I actually didn't use it. But there's some adaptation of this. Music brains, music, maybe useful. The question was, the good relations ontology, is it used for like catalog representation, and is it basically used for commerce? And the question is, in theory, yes. When I read it, when I read like the properties, right, the useful stuff, you know, like what can you say about the product? Like I got product X, right? What can you say about it in that ontology? What can you really make universal? What can I reuse? And they have stuff about like pipes and like open hours. Like I'm on the web, I don't have open hours. I'm open 24 hours, right? So I found it kind of weird to use, so I didn't use it. Having said that, there's a pretty wide adoption of this thing. So for some use cases, for some stores, online stores, there is an adoption. Like I think Best Buy is using them for their microformats RDFA because Google actually recognizes. They announced like officially that they announce that they recognize this library. And if they see it in your page, they'll add something like a star rating or a little picture next to, you know, like a rich snippet next to your wherever you come in the search rankings. Given that you are in the top 10 of commerce research results, which everybody knows is like an impossible thing to achieve because you're under Amazon, Zappos, whoever, right? So if you're that impossible 0.1%, you get a rich snippet, which really increases your click-through rate by like 20%, which is good if you're there. So I know it's used for that, but I haven't found use for it. But it's meant for commerce. So these are like companies, Twine. This would be a good question. I don't know if you're doing questions. But it would be a good question of the day of who knows which companies had an exit / quote exit quote failure in the recent months out of this. Any guesses? Very good, Twine. So Twine sold their company, the company assets to another company. And I think there was a big debate. And this is a very interesting topic because they were like, there was an article in 2007 about the top 10 semantic companies. They're going to be the next, this is the next thing, right? 2007. Web 3.0 is coming. And Twine they're actually a San Francisco-based company. And Twine was one of them, and they had all this PR, and it was great. And they were kind of the social network. That's big still. So in theory, they shouldn't have failed too much. But the question was like, okay, you got this cool technology. It makes use of all the stuff, but what problem are you really solving? And this was like never answered, right? So they built the company backwards, and they kind of made some cool technology, and they had to kind of sell it. They made it look like it was successful, but I think the industry word was that it was like, investors weren't happy, and all this stuff. So that's kind of what happened. France is very successful, I think. As I understand, these guys, I'm not sure, top quadrant. Where's my? Top quadrant. I don't know because I don't know how successful they are because the adoption. So they're selling like things for you to edit taxonomies, right? But there's not been a big adoption of semantic technology, so I don't think they have a big user base. The most is in the tens of thousands, and they have to have invested $gajillion to build that thing. It's pretty good. And the people that it takes to build such a thing, they're very expensive. So I don't know how successful they are. Freebase, nobody's using it in this room. And you guys are like the early adopter crowd, right? You guys are technologists. So I don't know. They got a big investment. They have a couple-year runway. OpenLink, I don't know. Twine, These guys are very successful. These guys, Adaptive Blue, out of New York, not pure, like I mentioned them earlier, not pure semantic company. They actually went away from semantic stuff. They were more semantic, they had some use case for it. They were more semantically oriented. And then they're like, you know what? The other things are actually catching on. that aren't semantic. So actually, they're like a 4 or 5, or they're a very small team, and they're really successful. I don't know what their revenue numbers are, obviously, but I know they have had a wide adoption. And people who are using it, they're using it like they love it. So one of those. Books, if you are still interested. I like this one. It's my favorite. I have it. It's very, like, for programmers, probably the best. It's like gives you, it's so well written, like person talking to you, and the examples are there, and it's just like very detailed, but not too boring, you know. So we did like an overview. Do you guys want to like geek out and see some code? Wow, you guys are going to see code, all right. Okay, so if you want to program the stuff, it's actually like pretty simple. Thanks to Shimad. There's really only like a few things to cover, okay? Some of the things in the API, the database, this ARQ is like a legacy thing. It's kind of going away. Just focus on the Sparkle. SDB, TDB, same thing. SDB is kind of the slower thing. TDB is actually a competitor of the Franz database software. And it actually it uses the file system. So it doesn't have like it basically uses the TDB is said to be very fast, like orders of magnitude faster than this SDB, which is going away. So just focus on TDB. And TDB is like uses the file system, is very, very fast. And it's like super easy, as you'll see, to configure. Like really easy. Like nothing like connecting to Oracle. Like, because even that's like a one line, but still you kind of have configuration problems, but this is like way. And then like inference, you know, palette, stuff we already talked about. Once you get all the stuff working, you can do some stuff on the data. All right, so this is actually is VCard. So anyhow, you have a very simple thing. Whatever, you know, John Smith, his name is John, family name. You know the story, every hello world. Okay, so this is the code for the, in Jenna, by the way, it's open source. It used to be owned by HP, and it was always kind of open source, and they just, HP stopped supporting it, and now just open source package out there. It's pretty, you know, you just drop the jar into, and a couple of jars into your lib, and then you're just ready to use this in your code. And then when you're writing the actual code, basically there's a few things you want to, so do you remember this URI kind of thing? You know, where you're just defining, then you give in, this is like the actual name, and then you make a string. This is very basic, right? Like nothing new here. What kind of, the first interesting thing is here, where just one line, and you created a model, right? So this thing you were trying to like, that you would have manually have made into a, you know, like a taxonomy, a library, an ontology. You just made it, right? That's your model. Your model is the graph. Okay, and then you're just doing very simple stuff, right? You're saying that this URI, it's like a resource. You know, it's either an object or a subject, right? It's some kind of a resource. And then you're telling it, you're giving it a very standard property, right? VCard full name, and that. And you're saying create the resources, and then you're adding all the stuff to the model. Where's the model? Or actually to the resource, because it's like a dot. Sorry, it's hard to read from here. So that object, you're doing all the stuff to this resource, right? You're telling it has a property, another property, blah, blah, blah. Okay. This is kind of how you manipulate the data. Yeah, some things you can do with it. Create the model. This is like the flavor of the model. Like there's different owl flavors. You really don't want to get into that. It's like just use model. Pretty much does like 90% of stuff. And here, create model. It looks like it's going to infer stuff. So you made, so there's kind of this concept of individual. An individual, it's something like very basic, right? So like you know, you have a dog is a class, but like some dog, it's one dog, right? You don't need to generalize it. It's just like some dog with that particular dog, right? So you cannot generalize that thing. So in general, it's an individual. It's not an abstract entity, right? So the actual example of the dog, right? The concept of a dog, that's a class. But the individual will be like the actual like one dog, right? So this is the very basic thing. When you get to the bottom of a taxonomy, that would be the individual. So you're kind of saying an individual can be a resource. It's like it's not that strict, but basically you're kind of saying that that's what it's like the basic thing, right? And you're telling it that. Here you're declaring stuff. You kind of made a model which is called base, and then you're reading things in, right? So you're reading a library in there. So this is like the general stuff you can do with your data that you read in the library. What I was kind of like hoping to see, well, this is the example of the queries that we saw before, right? Prefixes. What I was hoping to see is TDB stuff, because you kind of start here, because really you need to have your data somewhere, right? It's in your TDB, and the TDB is like your repository. So it's so simple, right? You just say where it is. It's basically, this is like a directory structure, right? And then you just say create the model, and then you're just say, and that's it. You can use this model, and whenever you're done, you close. But the actual, and the thing is, if your TDB doesn't exist, if it's like new, it will create it for you. But if it's the very same code, if it already exists, it's not going to like recreate it for you. It's actually just going to reuse it. So it's just you using the same thing to create it and to connect in the future. So just 2 lines, pretty simple. Okay, so this is interesting. This kind of stuff I was trying to fish out of the first example. How do you infer stuff, right? So you have a model that you read in this owl library, right? Something owl demo schema, some random something made, right? But it's written in owl. And then you say you load it, another one, right? So it's kind of like you get this from here, and then you kind of do this combination where you combine these 2 data sets. You take one data set and another one, and then you reason over them, right? So you like merge these 2 sets and see what logic. It's kind of like the whole idea of combining graphs. So this is where really like interesting thing. You're taking 2 different models, right? You have one model, and then on the next line you make another model, and then you're declaring the reasoner, and you're saying the reasoner, like right here, right? You're binding schemas and then creating an inferred model. So what happens is like it's like a big deal thing, but you take a couple of lines because you took 2 graphs, you put them together, you inferred stuff over them, and then now you have all this new data. And it's actually like you did a lot. If you think about it, it's like doing a lot, but it just takes like a few lines. And this is really powerful stuff in Jenna, because it has such a big library, but the useful stuff is so easy that, like in my experience, I use maybe I saw the library and I saw the API, and I'm like, don't need. Oh, perfect! It solved my problem, and it was just so easy. And that was my experience with Jenna. They do make like the things, like very practical things, are easy. All right, so that's it. Thank you.